The topic that we are going to discuss today is H parameters. You know what is a two-port network? Two-port network consists of two ports. The input port and the output port. With a two-port network, we can define different parameters. We have already gone through some of the parameters like Z parameters, Y parameters, ABCD parameters, and today we are focusing on H parameters. This hybrid parameter representation is widely used in the modeling of electronic components and circuits, and particularly transistors. While defining a transistor specifications, we will be considering this H parameter values. H parameter got its name from the term hybrid parameter. The term hybrid refers to a mixed up effect. For all other parameters, we were considering voltage terms or current terms or input side values and output side values. But here we are considering the terms in a two-port network in a mixed up manner. Here we can see that the input matrix consists of voltage and current values, and that too of the input port and the output port. And the last matrix is also like that. It is also having current and voltage term of input port and output port. So the hybrid parameters define a mixed up effect of voltage current terms in the input and output ports. The hybrid parameters are defined as H11, H12, H21, H22. We can express this in equation format. V1 is equal to H11 into I1 plus H12 into V2. Likewise, I2 is equal to H21 into I1 plus H22 into V2. The evaluation process is also having a mixed up nature. In the output port, we'll do short circuit, and in the input port, we'll open circuit. First, we will consider the condition short circuiting the output port. We now know when a port is short circuited, then the potential difference across that point should be considered as 0. So, V2 will become 0. We can substitute the value V2 as 0 in the above equations. For the first equation, this term will become 0, and we can have the rest of the expression as V1 is equal to H11 I1. From that, we can get the value of H11 as H11 is equal to V1 by I1. Applying the same condition in second equation, this term will become 0 and the remaining will be I2 is equal to H21 into I1. From that, we'll get H21 as I2 divided by I1. So from the first case, V2 is equal to 0, we'll be getting two parameter values, H11 and H21. H11 is equal to V1 by I1 when V2 is equal to 0, and H21 is equal to I2 by I1 when V2 is equal to 0. We'll go for the second case. Our second case is open circuiting the input port. While open circuiting, the current loses its path. So, we can take the condition as I1 is equal to 0. We can substitute this condition to these two expressions. For the first equation, this term will become 0. So, the remaining will be V1 is equal to H12 into V2. Now, we'll get the expression for H12 as V1 divided by V2. In the second expression, this term will be 0 and the remaining will be I2 is equal to H22 into V2. And the value of H22 will be I2 divided by V2. So from the case I1 is equal to 0, we have obtained two parameters H12 and H22. H12 is equal to V1 by V2 when I1 is equal to 0 and H22 is equal to I2 by V2 when I1 is equal to 0. Each parameter has got its own name. We'll first consider H11. 11 indicates that it is seen in the input port and the relation is V by I. The V by I expression indicates that it will be an impedance value. It is obtained with the case V2 is equal to 0. That means the output port is short circuited. So altogether we can name it as short circuit input impedance. The next term H22, it is seen in the output port and the relation is I by V. The relation I by V indicates that it is an admittance term and it is obtained by open circuiting the input port. So we'll term it as open circuit output admittance. H12. H12 is a voltage ratio and the direction is seen from input to output. So we can term it as reverse condition and that too obtained by open circuiting the input port. So we'll term it as open circuit reverse voltage gain. And the last term H21. H21 is a current ratio and the direction is seen from output to input. So it is having a forward direction. It is obtained by short circuiting the output port. So we'll term it as short circuit forward current gain. This H parameter defines almost all conditions. We'll be getting the impedance value, admittance value, the voltage gain value and the current gain value. Let's try to obtain these values by solving a network. We'll try to solve a question. Find the H parameters of the network shown. We'll start with the step short circuiting the output port. These two are the output terminals. So we are going to short circuit this terminal. Here we can see another condition. There is a resistor just parallel to the shorted path. So current will not flow through this 4 ohm resistor. So we can redraw the circuit by neglecting the 4 ohm resistor. This will be our circuit. From the condition short circuiting the output port, we will be obtaining two values H11 and H21. We'll first take H11 parameter. The relation is V1 by I1. Like what we have done with the earlier parameter values. When the values of the numerator and denominator are not known, we'll be trying to make both the numerator and the denominator with same type of values. Here we'll try to change the numerator value and try to make it look similar with that of the denominator. V1 is the voltage in the input side and it can be calculated using the relation I into R. But R is not a single value here. We'll have to take the effective resistance. The effective impedance at this point should be calculated. So we have to start from the opposite side, that is from here. We'll start with the 2 ohm resistor and we have to check the type of connection by which it is connected to the next resistor. The resistor that is adjacent to this is 2 ohm resistor. This is joined to this resistor here in this point and also in this point. Here both the ends are interconnected. So it will be a parallel connection. After getting the impedance of this parallel combination, we'll consider the next resistor. The 1 ohm is connected to this parallel combination at this point, and here it is not connected, so this will be a series connection. The effective impedance can be calculated as 2 parallel 2 and that combination in series with 1. We know how to solve a parallel combination. We'll take the expression 1 by R effective is equal to 1 by R1 plus 1 by R2. So we can write it in another way, R1 R2 divided by R1 plus R2. Here it is written as 2 into 2 divided by 2 plus 2. And this is the series connection. By simplifying this, we'll get it as 2 ohm. And this can be substituted in position of V1. H11 can be written as 2 into I1 divided by the numerator I1. The similar terms cancel each other and we'll get the answer as 2 ohm. Let's move on to the second condition, H21. H21 is equal to I2 by I1. We'll try to solve this numerator term I2. I1 is the current that is entering into this network. And at this point, the I1 gets divided into two different branches. One through this branch and the other is through this branch. The current through this branch is termed as I2. So we'll get the expression for I2 using current division rule. The current division rule explains that the current through any branch will be equal to total current into resistance in other branch divided by total resistance. We need to find the current through this branch. It is called I2. I2 is equal to total current I1 into resistance in other branch. The other branch is 2 ohm divided by total resistance 2 plus 2. The total resistance includes those in the two branches. So the relation is I1 into 2 by 2 plus 2, and we'll have a negative sign here just because of the reverse current direction seen here. I1 and I2 acts in opposite direction. It gets simplified as minus I1 by 2. Now our numerator has become of I1 term, that is both the numerator and the denominator are now in terms of I1. So we'll complete the relation by substituting the value of I2, that is minus I1 by 2 divided by I1, and this gets simplified as minus 1 by 2. So the first case is over, short circuiting the output port. Now we'll do the second step, open circuiting the input port. Here is our input port, and if we are open circuiting these terminals, the I1 current will not find any complete path to flow through. So the effect of I1 current should be neglected, and hence the 1 ohm resistor will also become inactive. Considering these conditions, we will redraw the circuit. Our circuit will be like this. The parameters that we obtain from this condition are H12 and H22. We are first considering the condition H12. Here we have V1 in the numerator and V2 in the denominator. V1 is the voltage in the input port and V2 is the voltage in the output port. So these two terms are entirely different. We'll try to get expressions for V1 and V2. V1 is seen here. V1 can also be expressed as the voltage across this 2 ohm resistor because it is just parallel to this. IY is the current flowing through 2 ohm resistor. By using Ohm's law, we can write the voltage across 2 ohm as I into R, that is IY into 2. Here the total current is I2. This will be flowing till this point, and after that it will be splitting to two branches Ix and Iy. To get the value of Iy, we'll be using current division rule. Current division rule states that current through any branch is equal to the total current into resistance at other branch divided by total resistance. So we'll try to write the equation. Iy is equal to total current I2 into resistance in other branch 4 divided by total resistance 4 plus. In order to write the sum of resistance, we have to consider all the components in these two branches. First, we have taken 4 ohm. Now, this branch is having two resistors connected in series. So, the effective resistance should be calculated. It is 2 plus 2. Now, we can simplify this equation. I2 into 4 divided by 8. We got Iy as I2 into 4 divided by 8. It gets simplified as I2 by 2. We can substitute this value in this relation. V1 is equal to I2 by 2 into 2. And we'll get the answer as V1 is equal to I2. Now we'll try to get a relation for V2. V2 is the voltage at the output port. It can also be defined as the potential across 4 ohm resistor because this 4 ohm is just parallel to V2. So we can write V2 as V2 is equal to I into R. Current through 4 ohm is defined as Ix. Ix into 4. Ix can be defined using current division rule. Ix is equal to total current I2 into resistance in other branch. The other branch is having 2 and 2 in series. So we'll take it as 2 plus 2 divided by total resistance 2 plus 2 plus 4. So we'll get the answer as I2 by 2. Now we can substitute this value into this expression. V2 is equal to I2 by 2 into 4, that is equal to 2I2. Now we'll try to complete the expression for H12 by substituting V1 and V2 values. We got V1 as I2 and V2 as 2I2. By simplifying, we'll get it as 1 by 2. One more parameter value need to be found out, H22. H22 is having I2 in the numerator and V2 in the denominator. We'll try by substituting the value of V2 in this expression. V2 is 2I2. H22 becomes I2 divided by 2I2 and we'll get this simplified as 1 by 2 mho. The unit mho is given here just because this is an admittance value. So we have come up with our final answer. H11 is equal to 2 ohm, H12 is equal to 1 by 2, H21 is equal to minus 1 by 2 and H22 is equal to 1 by 2 mho. H11 was an impedance value, so we gave the unit ohm. H12 being a voltage gain, it won't be having any unit. Similarly, H21 is current gain, so it will be a unitless quantity. And the final one, H22, was admittance value, so we gave the unit mho. If you are thorough with the evaluation steps, you can solve more problems. So try to solve other questions by yourself. Thank you for watching.